So now in this small but hopefully growing section of the family economics, we're not going to talk about spousal interaction, but we're going to talk to parent-child interaction. So before I go into the kind of the details of this paper, let me give you just an idea what the research agenda of this project is. So what we want to do here is to study human capital, the development of human capital in children as an equilibrium outcome. An equilibrium outcome of the interaction between parents and children, okay? So the novelty here is that essentially the starting observation is that much of the development of your own human capital is the result of your own behavior. And you may imagine time allocation choices or the use of drugs or things like this during adolescence that have an impact on human capital. And on the other hand, the other observation is that these choices are not something that parents cannot do anything about, okay? So you may kind of adopt a more controlling parenting styles, impose more rules, you may want to provide monetary incentives, but the punchline is that parents do not take as given the behavior of the child and try to mold the children's behavior. And so it makes sense to kind of wonder what is the impact of parental incentives as opposed to what has been done and which is still being done by people like Flavio and Heckman and so forth, which is the analysis of parental inputs. So what is the conceptually the difference between inputs and incentives? Well, the difference is that inputs go directly into the human capital production function, okay? And incentives do not do so necessarily, okay? So then of course, in order to approach the issue, what you need to do, one of the things that you need to do beyond experiment is to model parent-child interaction and address this issue. So this is kind of the broad research agenda. What specifically this project is about is a paper about optimal parenting, or maybe I should say, for what I'll do later, suboptimal parenting. So by this I mean, so what this paper wants to do is to address this debate which is becoming more and more popular about what is the right way to rear a child. And the observation, both anecdotal evidence, but also data I'll show you later, suggests that there are very different philosophies, very different strategies, and it's unclear whether a more tiger kind of parenting is more effective than an approach based on self-regulation. Okay, certain parents and certain researchers found that giving a certain degree of autonomy to the child, gives a sense of responsibility. So it's to prefer to an approach in which the child is always subject to strict rules. So this is what I want to do, and this is not just a curiosity or a cute kind of thing. It has consequences also for public policies. Okay. And so the public policies I have in mind are bans, prohibitions, curfew laws. So all those public policies that eliminate or kind of lower parental monitoring costs. So the idea of all these policies is that the implicit idea is that strict parenting is good because if parents cannot monitor the child is left to himself, and then that's it. Okay. So here instead, what I'm going to do is to propose a model which captures a trade-off. That is, why is that is not always optimal to be strict. And the innovation here with respect to what we have so far is that this trade-off is generated by dynamics. So the intuition is very simple, and it just can be described by saying that if the child anticipates that no matter what, there's always going to be strict rules or, say, low transfers, then strict parenting is not necessarily ex ante superior. So then the difficulty here that I was faced is to kind of get a tractable framework to bring models to the data. And so essentially have a model which have a dynamic game which then you can somehow estimate, and the overall goal is to kind of run these thought experiments, okay? So now, with respect to what we have so far, the main innovation is that I'm going to have players being both forward-looking, as opposed to what typically the literature does, which is to assume that one of the players is static. So here, by dynamic, I mean that both the child and the parent incorporate in their current decision the consequences of their actions, okay? And typically, this is a good approximation when you think about children who are very young, but perhaps when you deal with teenagers, assuming that the child doesn't care about the future is a little bit extreme, and still, of course, it's a way of capturing the conflict, but it might have consequences on the answer you get on this issue of optimal parenting. So now what I did was started difficult and got easier in a sense. So what I had in my dissertation was just a two-period model with a more complicated kind of information structure in which I had adverse selection. So I had a model of equilibrium learning. So what you see today is an extension of that work in which I remove this asymmetric information. I keep moral hazard. I'm going to have a fully dynamic game that is I'm going to look at equilibria that hold in an arbitrary finite horizon setup. So these results I show you today will indicate that dynamics is important to understand the effectiveness of different strategies. Okay. So now let's just get a feeling of what this data I have, or this data I'm using. So there are these, in the NS 97 questions, parents and children in one round, and then after the first round, also just the child about who is the person that makes decision about these three activities, okay? This staying with friends, or watching TV, and you know, what time you have to come back home. And there are these responses. So I'm not going to think of this as literally, okay, as what's going on there. I'm not going to think. I'm going to consider them, use them as a proxy. But still, I think they're indicative of what's going on in terms of how controlling parents are. And what I liked about this data is that there is quite enough cross-sectional variation in terms of who is the person. So there is both a cross-sectional variation and there is an age pattern, okay? So there is parents, so you see more parents typically would choose the curfew, most parents would leave the child aside or would give to the child some role in decision about the friends, and then also less parents then the curfew would decide on the TV limits. But you know, there's quite enough heterogeneity on the responses. So then
who's answering the question?
So in the first round, both the parents and the child, and after just the child. And then you would see, of course, some disagreement, but usually they kind of agree on who is the person. So then this is not just it, okay? So in this data set, then they ask the child, did you break the limit in the last month? How many times did you do it? They ask the child what would happen if your parents found out that you did. So I have more analysis on this on the paper, but the idea I got is that parents kind of enforce this, because the majority of these children declare that they do not break these limits. And so I thought then they were a good way to start. So then there is, of course, there are some interesting patterns when it comes to the correlation with race, because you would observe that blacks would be stricter. So black parents enforce stricter limits than white parents, and Hispanic are somehow in the middle. Okay, so then of course you may also want to wonder whether you can generate this kind of cross-sectional variation across race. And the other pattern I don't have here, but because I'm not going to look at the paper, is also counterintuitive for some people, which is monetary transfer. If you look at the data, black parents, although controlling for income, give more allowances to their children. So very, very counterintuitive things that you may want to rationalize. The other thing is that, that the model wants to target is a negative correlation between the strictness of the limits and measures of achievement. And that is, more human capital the child has, the less likely the parent is to decide. Okay, so if you know more, then I'm gonna let you go. Okay, I'm gonna be less controlling. And so this is kind of the justification for subset of for a class of equilibria that I will propose you later in the model. So this is true for various measures. It's more true for the PIAT than for the GPA, and but it's there. So this is the bigger kind of thing. Okay, so now what I'm gonna do is to propose you a game, and it's gonna be admittedly a stylized game. But the good thing about this simplicity is that I'm gonna be able to characterize the equilibria, okay? And because there might be potentially multiplicity, this is gonna help me in recovering the primitives of this game. So this is gonna be a very kind of crude approximation of reality in the sense that it's gonna be a model in which the parents and the parents wants the child to study, there is miscongruence in preferences, there is no paternalistic view, okay? In other words, what the parent does is just because he wants the child to study more. And the parent will care about the leisure of the child less. But there is not gonna be some kind of time inconsistency that you may legitimately wanna pose there to justify parental intervention, okay? So there are going to be two forward-looking players, and then there's going to be T periods. As I said, there are no behavioral differences, just a mismatch in preferences. In here, just to clarify, that there's going to be leisure, and then there's going to be human capital, which is the only set variable, which accumulates dynamically. And so what the stage game is somehow simple. So what happens is that so this is going to be full information game. Okay, so the parent and the child have common knowledge about everything. I know the human capital of my child. I know the technology. I know everything. So I'm going to discuss a bit later what are the issues here in putting adverse selection. Okay, so. Learning. So this is going to be, if you think about Flavio's story, so it's very appealing, but here it's going to be a little bit more difficult. Well, not more difficult, because you're not going to be talking about equilibrium, statistical learning. You may want to introduce, if you have learning about some parameters, you're going to have equilibrium learning. And so things become complicated. But I'll tell you why I think that this approach I'm taking is promising in that direction, okay? So then the parent knows the human capital of the child, and it's going to be a standard principal agent model in which the parent moves first, and then the child responds, and then the human capital of the child realizes, and then the game is repeated. So, so what the parent does is to choose a parenting style, and I'll tell you what the parenting style means in this context. And the child chooses an effort level. Effort level here is how much time the child decides to allocate to the production of knowledge, okay? And total available time is normalized to 1. This can be generalized. You can have effort. So here there is just effort and leisure. You could have effort and multiple leisure activities, okay? And then, as I said, so this is going to be a repeated game. So here, what really I'm after is to think about the dynamic production of human capital as the result of the interaction, in the sense that as much as paper like Heckman and Flavio's paper characterize the substitutability or the complementarity of the technology, here there's going to be still complementarity and substitutabilities depending on what limits parenting rules do. to the effort of the child. And so there's going to be, essentially the model will have to generate the pattern, for instance, of inputs. So in here, I showed you before that as the child gets older, the parent is less likely to be controlling. So the model will have to generate that, okay? So only here, the technology that you have to think about is really the game itself. That is this action spaces, the information set, okay? And so the child would just care about his leisure and he cares about his final level of human capital, okay? So this is what can be called the adult human capital. Then I'm going to show you how I map this to the model so you have a better understanding of what KT plus 1. KT plus 1 is going to be, say, the human capital of the child at the graduation of high school. But so then these are both increasing. The parents doesn't like to be strict, okay? So stricter limits will imply a higher monitoring cost. So the first restriction that you see here is that there is no altruism, strictly speaking. In other words, I'm not plugging the utility function of the child into the utility function of the parent. And this is for convenience. You still have that the parent doesn't like, it's not because it's altruistic, it's just that he has a monitoring cost. Okay? Of course, which specification you take might have different, of course, welfare consequences. So here, there's going to be dynamic, and there's going to be dynamic. So in here, there's going to be in essentially both, let's say, cognitive skills and non-cognitive skills. So K is cognitive skills. K is the human capital tomorrow, which is a function of the effort of the child and the current stock of human capital. And there's going to be first order stochastic dominance. If you study more, then it's more likely you're going to have more human capital tomorrow, and more human capital you have now, it's more likely it is that you will have more human capital tomorrow. So this is so the dynamic stems both from here, but also stems from another channel which I introduced, and I'll tell you why, which is non-cognitive skills. Non-cognitive skills is generically captured by a multiplicity of traits. That could be the risk aversion parameter, could be discount factor, could be preference for leisure. In here, I introduced this specification, which is essentially the Becker-Murphy theory of endogenous preference formation, which the human capital increases, the discount factor increases with the human capital, okay? So the more human capital you have, the more you care about tomorrow, okay? So this is endogenous preference of formation of preferences. So here there is both cross and self-productivity, because if I have more human if I have a higher discount factor, then I'm going to discount the future more, so I'm going to study more. I'm going to study more, and then I'm going to, because of this self-productivity, produce more human capital tomorrow, and then that's going to generate higher non-cognitive skills, and so there's going to be this correlation between these two aspects, the stock of knowledge and the human capital. So now, what is the link? So here, essentially, there are different ways of working with this, but this is, from my experience, much more convenient than another one. I'll tell you later. So here the child will solve his maximization problem, which is just decide how much he wants to study, subject to a parental constraint. The parent, this is kind of the Tiger-Mitre effect, okay? The parent goes there and says, okay, you have to study more than this. It's not going to be so easy. There's going to be a more realistic aspect in the model, but that's the link. You could think about other ways of linking the child and the parent. Maybe the limits would say, what I had is the limits, they could change the margin of productivity, margin utility or leisure, okay? They enter directly into the preference parameters. This is more difficult to work with, and I'll show you why. So why now, however, the parent cannot perfectly enforce a tau, and tau, I'm going to think of tau as a random variable, whose realization are affected by the parenting styles. Okay? So stricter you are, the more likely is that tau is going to be higher, the more likely is that the child will study. Okay? So say that you impose strict limit, you put I don't know, parental control on your TV, then it's more likely that leisure activity is not accessible to the child, and then he's going to study more. And this is just for the stochastic dominance. So I'm going to order essentially parenting styles in this way. Stricter parenting style will induce a higher tau. So now, just to preview, so what I'm going to do now is to focus on monotonic equilibria. And I think that looking at this monotonic relationship is meaningful just because also the human capital production function literature is all about complementarity and substitutability. But also because I'm going to be able to tell you more about how the equilibrium look like. So this is the order I have on the parenting styles, and then how random this is, how randomness. Say the more tau is the generate condition on a row, you may think that less severe the moral hazard is. Complete moral hazard would be a problem which I cannot really control and enforce a strict tau even if I impose a high row. Okay, so moral hazard here is given by this randomness of tau conditional on row. Okay, so higher the variance of tau, more pervasive the moral hazard problem.
So here, in this model, there's no ability. Is there?
Sorry?
There's no ability here.
No. So here. Here you may think of ability as indexing F. So differential, so ability you mean permanent mental ability.
Yeah. Because it could affect the parenting style. I don't know whether we have a
Sure. So I'll tell you later what for now the theoretical model will incorporate different ability as different F. Okay.
So question about the technology of learning and this uncertainty. It's all child specific, so there's no kind of patterns that are going to be different across birth order.
So now again, so now I'm going to think about everyone is then I'll tell you.
Child-parent relationship is unique.
Yes. So then later I'm going to tell you because it's really about identification. So you can put heterogeneity here, you can put heterogeneity in the F, you can put heterogeneity everywhere. But let's see first the mechanics, and then I'll tell you. Okay. The other reason why I focus on monotonic equilibria is precisely because of this. Given data limitation, if you have monotonic equilibria, you have monotonic equilibrium relationship that you can invert. Okay. And given a certain data limitation, this will turn out to be useful. Okay. So now these are just standard histories, standard repeated principal agent model with no commitment. That's very essential here. The parent cannot commit to a predetermined course of action. Okay? You may want to think about using the estimates of the model to try to understand the welfare losses coming from the inability to commit, but in the characterization, I am abstract from commitment. Okay, so this is just the Bellman equation of the child. It's just choosing A. That's standard, and there is the parental intervention here. Okay. So now, however, the parents will take as given A, the best response of the child, which I will denote A tau of K, and he's going to incorporate that in his value functions in his program. Okay, so I'm gonna essentially plug A tau K here. So just one clarification. So what I showed you before in the primitives is what is called I don't remember the name, but what this does here is to avoid to separate the shock from, in other words, this is just a CDF of the K. Okay, this is not a state space representation of the production. Okay, this is a convolution of effort, human capital, and the shock. Okay, this is non-unique, meaning that to each F there might correspond different structural representation. Okay, usually we work with the structural representation, which you have human capital, you have effort, and then you have a shock. Here it's just a CDF, and this is going to be very crucial to help me to get around the problem of characterization. Okay, it's also different in what you can get in the standard principal agent model. This is a paper by Conlon on econometric with multi-signal that exactly specifies what are the advantages and the disadvantages of working with one representation of the other representation. Okay, so now this is just standard. Single crossing and increasing and decreasing differences. But what I'm really gonna wonder here is, given this problem, okay, given this problem, what are the conditions, okay, on the primitives? That would be u, the terminal value functions, the production function, such that at each period, the parent finds optimal to punish the child when the child does poorly. Okay, so it's very kind of narrow-minded equilibrium in the sense that you may well imagine that there are no monotonicity. When you're really bad, I let you go. When you're kind of an intermediate level, okay, then I intervene, and then I let you go again. Okay, I don't. So lenient, strict, lenient. But for multiple periods, the characterization is going to be more difficult. So instead here, let's just focus on these equilibria, which have been used in other literature, the economy literature, for example, in which you do bad, I punish you. Okay, this is the standard. By the way, this is the standard principal agent. All the question about the principal agent model is to find conditions such that at good performances follow rewards. In here, rewards is lose limits, okay? So standard principal agent question. So then there is this Milgram-Shannon, this is standard Milgram-Shannon theorem. This is the question I want to address, okay? So now what you need to apply, what you need to have to apply Milgram-Shannon is that the objective function of the parent has single crossing in K rho, okay? Now you want to, however, this task is complicated by the fact that you have a non-primitive object here, okay? And what you want to do instead is to place restrictions on the primitives because you want to estimate this. So how do you get around this? Essentially, the problem is that what the Milgram-Shannon gives you is, and the literature of monotonic comparative statics is to give you conditions on the objective function such that there is monotonicity. But what we are wondering here is whether a best response has the single crossing property. Okay? Why? Because the intuition that I'm going to follow is going to be like this. So instead of single crossing, I'm going to work with the stronger version, which is decreasing differences, which is a sufficient condition for single crossing. I'll tell you later what goes wrong with single crossing. So how it's going to look like, the best response of the child? Well, suppose that the program of the child is concave. It has unique maximum. And suppose that the human capital of the child is, the effort of the child is increasing in the human capital. So now the best response at a given level of human capital is going to be flat, and then there's going to be binding. So here there is tau, okay? If the constraint is not binding, I'm going to choose my global maximum. After, I'm going to just be binding because the objective function is decreasing, okay? So this is the single call. When the effort is increasing in the human capital, at higher level human capital, of course, the ET kappa H will be higher than this, okay? That's it. That's pretty much what's going to lead the characterization. The observation here is that this function, E tau k, has the decreasing differences property. You see that the distance between these two curves is decreasing. Okay? So now let's do it even kind of more general. Suppose that you have a general objective function with multiple global maxima. Let's forget about quasi-concavity. Well, it's going to be like this, and you can easily show that the best response is going to be flat, then it's going to be, there's going to coincide with the 45-degree lines, then it's going to jump, then it's going to coincide again with the 45-degree lines. Now, it would be tempting to conclude that when you remove the requirement of single crossing, of single pickedness, then you get single crossing, but you don't. This, if you can show that when you remove the quasi-concavity, even if the best response is increasing in the human capital, this best response will not satisfy single crossing per se, but a broader version of a single crossing, which is the interval dominance order, which is being introduced recently by Quine-Strulovich. So this may look like to you, just speculation, but it has profound consequences on the sufficient conditions you will get. Why? Because single crossing and the interval dominance order are ordinal. In other words, if I knew that the best response of the child as the single crossing, this whole piece here is just an increasing transformation of the single crossing function. And then I will know that at least this part is a single crossing. What is the problem? Problem with single crossing, and therefore of removing the assumption of single peakness, is that they're not, the single crossing and the interval dominance order are not summable. And here I have a function that is summed to this. This is not true instead for decreasing differences, because if this is decreasing differences, I sum any function, there's going to be still decreasing differences. Okay? So that's the intuition that I'm going to follow to give you the sufficient conditions for the characterization. Okay? So what the game here is going to be to find conditions on the primitives such that the decreasing differences property is preserved. And that's going to be true. The cool thing about working with this representation that's not going to depend on the time period. It's just everything is in here. All the action is in here, and that's it. Okay, so let's see what these sufficient conditions do. So this is the theorem. They say that whenever the best response of the child that these two properties is increasing, and there is a unique, so it's actually a function. It's not a correspondence. Then you're going to have the property that I described. The parenting rule is going to be more lenient as the child increases human capital. So now this is going to be essentially the price you'll pay. So standard in the principal agent model, standard yet not so good. Well, that's kind of the failure of the principal agent model. You know that this comparative statics holds under not so general conditions. But I'm going to assume that F2, I'm going to assume two things. First is that there's going to be separability between essentially effort and human capital. Okay? So this is just going to be essentially, think of this in the standard formulation as human capital tomorrow to be the sum of effort plus human capital today. Then I'm going to assume that Q is concave. And what's going to be the case is going to be the case that the monotone comparative statics I'm after will result. Okay? And I want to go into the details, but this is just given by an approximation of increasing function done by Conlon, used by Conlon, which essentially approximate an increasing function as a sum of step functions. Okay? And that's all it. Then essentially the only thing you need to worry is that G, the fact that tau is stochastic, conditional on rho, and that's going to be preserved by a result by Vives and Van Zandt. Okay? So just to sum up and to give you more of the big picture where this stands. This is not strictly speaking a supermodular game, but even if it was a supermodular game, the static game will not, the strategic complementarities of the static game will not necessarily translate into the dynamic game. Okay? You will need conditions that are provided by Vives on the endogenous object. And that's not very useful if you want to estimate the model. You want to have conditions on the primitives. So what these properties of the best response function does is to allow me to find conditions that I can implement while I solve the model for a given set of parameters. Okay. So now I only have 10 minutes. So this is most of the things. So there are going to be different measures of time allocation. And in these results that you show, I'm just going to have time spent studying and leisure. So two goods, but what you can't see in the data is that there is a lot of time spent watching TV. Okay, it's a very interesting topic, I think, trying to understand the impact of parental intervention on TV shows, and the data show a big variation in time spent watching TV across races, and also a strong correlation with educational outcomes. So maybe you wanna, what I'm doing now is to incorporate two time allocation choices.
Are you controlling for family structure
In these tables, not. But what I can tell you is that there is not much difference. I was surprised myself. Okay? So actually, there is more or less different, depends on the type of limit you look like. If to think about the limit. In here, there is not much of a difference.
Wait, there is going to be, I mean, right? Am I
Sorry?
wrong? There's going to be a lot of difference across groups, right? In the family structure. Black.
Sure. There's going to be, no, I was referring to the parenting styles. With respect to the time allocation, of course. In fact, there is most of the black children, you know, that they live in single parents, so clearly they will watch more TV. But so now what is the problem here? The problem is that I gave you a characterization on the equilibria, and I know that all the equilibria have what I call this property, which I call the punishing strategy property. There's going to exist, because these are discrete choices, there's going to be a matrix that will say that whenever you move to the next region, I'm going to punish you more or less, okay? In a monotonic way. Monotonicity implied by the order that I imposed on the G. But if you are willing to assume that either you or the CDFC holds strictly, then you're also going to have that the response of the child is a function. So the best response of the function is unique, given a set of parameters and given an history. But what the problem is that C might not be unique. Let me show you why. So first of all, let's go to the data, and let's see that there is here, in time spent watching TV, both an intensive and an extensive margin issue. It's not that everyone spends time doing homework, okay? Just look at the blacks. 12% of them do not watch any TV. So you need to account for them. The model needs to generate a mass at 0, okay? Having said that, what is this? So what's the part, this is just the equilibrium. The equilibrium says that there are two actions. One is stricter, one is less stricter. The stricter one gives you better outcomes, but costs more. So see, this is kind of the different, these lines are the difference in two parenting styles, okay? So this function is decreasing because I proved it. So given a set of parameters, if this game was a static game, the probability that the cost will intersect a flat region coming from corner solution. So imagine a situation in which for two histories, no matter what you do, I'm always going to study 1 or 0. Then this function will be flat. We could theoretically intersect the cost. And then you have multiple cutoff. Now, if this game will be static, generically the equilibrium is unique. But because this game is not static, you're going to have additional parameters. In other words, the standard perturbation argument to show generic uniqueness doesn't hold because it is a multi-stage game, meaning that you move a little bit the cost, but then you're going to move also in the stage game, in the multi-stage game, also this function. And this is just clear from the dynamic problem solved by the child. Dynamic problem solved by the child is a function of the cutoff, but the cutoff is a function of the cost. So you move a little bit the cost, you could move a little bit that function. That cutoff matrix may not be unique, okay? However, we don't quite quit, and I'm going to provide you with an algorithm that is able to recover both parental preferences and the premise of the model in 2 steps. It's kind of inspired by several papers. Most of them started with Andrea Moro, and the game essentially takes advantage of the fact that conditional on a cutoff matrix, the best response is unique. So if I treat the cutoff matrix as an estimable parameter, set of parameters, then I can recover a subset of parameters, okay? I'm just saying whatever the parent is doing, I'm going to solve that program. I can solve it with standard methods, and I'm going to recover what? I'm going to recover the production function, the discipline production function, the parameters of the delta and the u, together with C. Of course, the problem is that, I've been dealing so far is that this adds a lot of parameters, okay? Because I'm going to map this with NRS-197 using 14 periods, which is the result of certain kind of aggregation that I thought were sensitive. So having to estimate this with 2 parental types gives me almost 120 parameters. So that's the cost you will pay. So once you've done that, however, now you know the cutoff, and that I'll tell you later, how I estimate the first step. What you can do in the second step then is to use the equilibrium condition as moments. So is it going to be point identification or is it going to be set identification? I think it's going to be set identification, generically. Meaning that at an indifference point, what I know this function A. So I know for any cutoff that I've estimated, so this is a number, this is a number, this is all a known quantity up to a set of parameters. This is a moment. So I'm going to have as many moments as the number of cutoffs in the game. Okay? So you're going to have typically over-identification. Because you have 14 periods, you have more, so you have, you have much more parameters than moments than parameters. Okay? This might still be set identification because this might not be, for a given set of parameters, this could be an inequality. In which case, you would have to recover parental preferences. You're not going to point identify parental preferences. You're going to have to use some kind of set estimator. Okay, so this is kind of boring. It's just that given that I placed restriction on the F and the CDF, these are just parameterizations. This is essentially the price you pay. Okay, this is principal agent model. Principal agent model, there is certain class provided by Likazzi in which the CDFC holds, and this is the parameterization I'm using. It's going to be the CDF is going to be the result of effort and current stock of human capital according to this summable power function density. Okay. Other than this, that's all. This is the restriction you need. Then you need concavity, but you can be you need concavity nu, but you can be as flexible as you want in the terminal values. Okay. So here I have these two parameter family. Okay, so now this is just the details. To me, they weren't details, but so here you have a problem of an observed state variables, and you have a problem of missing data essentially. One missing variable, the tau, is never observed. So you need to deal with that, and I deal with this. I use this method. Developed by Keane and Wolpin, in which you have to essentially only rely on unconditional simulations. Okay, so essentially you have a set of parameters. You simulate in the first stage, in the first step, an history which is a realization of limits of parenting styles, of effort and human capital, and then what you essentially do is to use measurement error to write down the probability statements. Okay, so the model is estimated using measurement error, which is not crazy, meaning that I would imagine that there is some measurement error, there is some misreporting. Self-declared time spent doing homework is also subject to measurement error. So that's what I did. Okay, so now I have only 2 minutes. So out of this, I just wanted to say that the most effective limit here. So it's interesting to kind of try to understand what is more effective in inducing the child to study. And it turned out that the setting limits on the curfew was the most effective tools, okay? In here, of course, the model needs to generate positive use of, positive probability of using all of these declared parenting styles. So now so essentially what the model does is to fit both the intensive and the extensive margin of time spent studying. So this is kind of what gave me multiplicity, okay? The fact that there is a flat region which is coming from the corner solution at 0. So then at least I want to fit the zeros, okay? The model does typically overpredicts the strictness, essentially. These parents are stricter than they should be. It fits also the transitions, which is another interesting action of this data. So the fact that certain parents are strict in one period and not strict in other periods, okay? So in that sense, the cutoff will have to adjust to fit these transitions. So now what I haven't done yet is the second step, which is the GMM to recover parental preferences. What really I need that for is to do welfare analysis. So what I'm going to do now is to use this model to run certain counterfactuals. I'm going to wonder what is that why don't we eliminate parental monitoring, okay? So why doesn't the government steps in and does it for the parent, okay? So essentially, I'm going to have this counterfactual, no matter what, wholly strict limits. And then the result here is that there are distributional effects, very low average treatment effect. But because of the dynamics, I still get both on the GPA and the PIAT. So GPA and PIAT are two measures that are related to, so I use a factor model here. The GPA and the PIAT are two measures that are informative about the underlying state variables that the parents condition their behavior on. And you would see that if you hold strict, then the lowest, the least able children at the age of 12, that is the one with the ability meant in terms of GPA, would experience an increase, but you would have a decrease for the more skilled children. Okay? So the intuition here, and that the result of this is that accounting for dynamics is important, because if you crowd out these effects, then you're going to be, I don't know what the size of the bias is, but you're going to certainly have a wrong answer, because the child is going to incorporate all the future action of the parent. And so if you're wholly strict, then, why should I just bother? I just be lazy, okay? So that's the importance of being dynamics. There are other dimensions that are not exploiting here that could be useful for identification, which I didn't have the time to discuss, which are multiple siblings. And then things get very complicated, because then you have the parents interacting with two siblings contemporaneously interacting. So tough. But the point here is that dynamic game for parent-child is an important issue. Okay? The other counterfactual is parent as a concierge. This house is not an hotel, so let's make the house an hotel. Meaning, I like to think of these are not public policies, but there are ways to think about the effect of this policy. And I get a negative effect for all of them with the same kind of pattern in which these ones are the ones that would study less, okay? The least stable. So just in the last minute, I don't have time, but just to point out that this is a growing area, and one will talk later about multiple children. And it's, it's parenting stuff, in all the sense. In the sense that we go into this domain of dynamic game, and I think that the lesson I learned is that monotonic equilibria are a promising way to deal with this. So this is what I would like to do in the future, multiple siblings. Monitor incentives, we have data, but difficulty in applying these tools. And then what you can do with this is welfare analysis and reshuffling. Let's assign, because here parents have different types, low monitoring, high monitoring, let's assign certain cases, a way of assessing the importance of initial conditions. But I was relieved that I did have this, in my market paper, this effect, but it was only 2 periods, but it's still there with relatively long time horizon.
Thank you very much.